So this is, it's called the on-demand. Every word has a meaning there. On-demand means you can go online over a broadband connection and use the service. Radically transforms the way in which you look at using design tools. Instead of buying a cray and installing huge amounts of software and having IT people tune it, etc., you basically go to a web URL, type in your password, and you have access to all this capability on demand. And the design optimization aspect relates to the fact that you typically have three phases when you're designing something. You design it, you simulate it, or you build a model of it, and then you can optimize it. And historically, you design something, then you build several models, and then you test them to destruction, you change the design again, and then you have the final answer. If you look at how Formula One operates today, you know, Lewis Hamilton's car and the aerodynamics of that car, they basically, until about 3 years ago, what they used to do, they would do the design work, they would build models, test them in wind tunnels, then they'd change them again, go back, etc. The design cycle was very long. Now, the Formula One guys have more computing power than Rolls-Royce. They have banks and banks of machines basically crunching numbers. But the point is that they can simulate the designs that you still can't optimize, so they might need to run 100 variants. What this service does is automatically iterate down to a solution that you would define the criteria for optimization. So a little like a hill climbing technique. For those of you familiar with the hill climbing algorithm, you know, if you're climbing a hill, you can go in many, many ways up a hill, but there may be an optimum path up a hill, which is the opposite of what mountaineers usually like to choose, because they want a challenge. Okay, so talk about creativity, because what I wanted to show you was how the early process of creativity works. So what happened in this particular case was, and this is 3 years ago, I met one of the professors in the engineering department from the University of Southampton, who basically said, I've got some wonderful grid computing technology. Basically what it means is you connect together a whole bunch of PCs, wire them together, run the correct software, and you get the performance of a supercomputer by using a grid. Right? So that was what he said, I've got. And I said, that's very interesting, but anybody will be able to do it now. What advantage does that give you? And he said, we've been applying it to very interesting problems in engineering. And introduced a second professor, who is the world's leading expert in optimization. Still is the world's leading expert in optimization. And he told me the day he signed over his intellectual property to this company, he said to me, you know, I've just given you my life's work, please look after it. And then he broke down in tears. Okay, these things can be emotional. And the third piece of technology, so I said, that's great, but none of this stuff is usable. And he said, Southampton hosts the UK's Semantic Web Initiative. Now, the UK government had poured £80 million into a new initiative called the Semantic Web Initiative, and it's about semantics. The Semantic Web Initiative basically allows you to change the way you input data, you take it out, so you can be more creative in the way in which you input data or you use the results, visualize them, display them, etc. And so this kind of led to a process. So we had three bits of technology. The Semantic Web Initiative has still had very little in the way of commercial realization. £80 million of UK taxpayers' money has gone in. It's not clear yet what commercialization will come directly out of many of those things. But that's not unusual. The optimization technique was being used by Rolls-Royce and BAE Systems. Two companies in the world were using it, nobody else. That's what it was. And grid computing was being used to provide high-power computing mainly for NASA and for the Met Office to come up with difficult forecasts or dubious forecasts, depending on your point of view, of the weather pattern. Right? For those of you aside again, it's almost impossible to predict weather more than 5 days out, although all the research scientists would like to claim it is, because it means they get more grant funding. There are inherent processes, stochastic processes in the upper atmosphere, which mean that you can't predict more than 5 days out with any kind of regularity. But, so, interesting, three pieces of technology. So, what do you do with them? And the act of creativity came in an interesting workshop, an informal workshop in a pub in Southampton. We were kicking the stuff around saying, well, what can we do out of it? They said, so far you've ripped everything to bits. What do you think we could do? And the answer was, is there a marketplace that we can think of that might benefit from this? And at that point, the optimization guy said, you know, SMEs, small, medium-sized businesses in the UK, would give their right arm to have this kind of capability. So I said, could we not create a service that could be delivered to these people? That, of course, interesting idea, and already the objections started coming through. It's too complicated. There are integration issues. How do you knit it all together? They can't afford it. What's the business model? How do you deliver it? And this thing you're seeing as the elevator pitch was the first slide that we wrote to present to investors for what we were going to do. We turned up and said, this is what we're going to do. Give us lots of wheelbarrows of money to do it. Okay, and so the idea was engineering, design, analysis, and optimization available over the web. And we said you can provide access to high-performance grid computing clusters. We're going to reduce computation costs by a factor of 10 to 1. Okay, that was actually, it turned out that was a conservative claim. And we'll significantly reduce design time. And we'll improve optimization. And then the other thing we said was, that's great, that's all the technology we'll do. We're going to change the business model. You're going to pay as you go. You'll only pay for what you eat. We're going to go for a mobile phone model for sophisticated high-end engineering design. And they laughed at us. Yeah? And we said, it's going to be available to all, you know, and they say, oh, these guys can't afford it, they know how to use it, they'll never pay for it. We said, well, that's where the market is. So that was active creativity. So with the key technology building blocks I've told you about, tools, semantic tools, high-performance grid, and optimization. And then we said, well, let's just try and understand where this thing fits. Who else is doing what in that space? And we began to understand that one of the creative innovations was knitting several technologies together. If we looked at any one technology, there were people doing their own thing in that space, and there were competitors. And it was in integrating all this together where the gap lay. Yeah? And then you'll see some of the tiering there was about the size of the customer. So there were people trying to do this, what we call tier 1, the top tier customers, and they had about 4 customers in the world. We were interested in having tens of thousands of customers, hundreds of thousands of customers all over the world. Okay, and so we said, okay, what's our go-to-market strategy in that case? We're going to focus on those SMEs, and then the ultimate ambition is to basically make the service available to anybody designing at home. So I can envisage a situation 5 years from now where you've qualified designer and you used to work in a company, now you sit at home, and you basically sell your services as a designer because you've got this most sophisticated design platform available to you. And just think about how the Industrial Revolution changed structures. This could be like another major restructuring.